This is a really cool problem, so see if you can solve it. A point P is placed at random in a square, and what we want to know is what's the probability that this angle alpha is bigger than pi over 2 radians, so bigger than 90 degrees. Alpha is the angle formed by the segments from P to the vertex A and from P to the vertex B. And you can see that in some cases, if P was all the way over there, the angle would be pi over 4, so 45 degrees. If the point was all the way down here, the angle would be 180 degrees. And if the point is smack in the middle, then the angle is pi over 2, it's exactly 90. And then if the point is somewhere between these P and P prime, the angle will be bigger than pi over 2. And if the point is above P, the angle will be smaller than pi over 2. But what is exactly the region that makes the angle be bigger than pi over 2? So if you want to think about the problem, stop the video here because I'm about to give the solution in 3, 2, 1. Let's work in coordinates. And what I want to know is what is the shape of the region where the angle alpha is bigger than pi over 2. And to know that, what I need to know is exactly what is the region where the angle is exactly pi over 2. I am working with a square that is 1 by 1. The point P is going to have coordinates A, B, and what I want is this line and that line to be perpendicular. But I can figure out what's the slope of this line, what's the slope of that line, let's call them M and M prime, and the angle will be exactly pi over 2 when those slopes are perpendicular, so when M prime is minus 1 over M. Now I can compute slopes, as we say, as rise over run, so M is B divided by A, and M prime is minus B divided by 1 minus A. So M prime will be minus 1 over M when B over 1 minus A is equal to A over B. Or equivalently, B squared is equal to A minus A squared, which simplifies to A squared minus A plus B squared equals 0, which reminds me of the equation of a circle, so let me convert it to that. I'm going to add a fourth to both sides, and that becomes the equation of a circle, A minus a half squared plus B squared equals a half squared. So that's a circle centered at a half comma 0 of radius 1/2. That means that the region where alpha is exactly pi over 2 is half a circumference of this circle of radius a half, and the region where alpha is bigger than pi over 2 is exactly this region over here, which is a half circle. And now the probability that the angle will be bigger than pi over 2 will be the area of the positive events divided by the area of all events. So the area of this semicircle divided by the area of the square. Therefore, the probability we were looking for is the area of the half circle divided by the area of the square, which is a half times pi times a half squared divided by 1, which is pi over 8, or 0.3926, etc. So the probability of the angle being bigger than pi over 2 is about 39%.